Good morning, students. The today lecture is RFID enabled access control with the components. Okay, this is lecture number 23. Okay, so you people are already familiar about RFID. RFID will be the radio frequency identification. Okay, by using the electromagnetic fields, which is automatically identify and track the tags attached to the object. This RFID, which consists of teeny radio transponder, a radio receiver, and transmitter. When triggered by a electromagnetic interpolation pulse means 0 and 1. Okay, pulse means 0 and 1. It will be a square signal from a nearby RFID reader device. So the tag which transmit the digital data means 1 and zeros, using an identifying inventory number back to the reader. This number can be used to track inventory goods. So there are two types of RFID tags are available. One is passive tags, another one is active tag. Passive tags are powered by energy. Passive tags are powered by energy from RFID reader integrated radio waves. Active tags are powered by a battery and thus can be read at a greater range. A greater range means a 1 megahertz from a RFID reader up to hundreds of meters. So you see this diagram. This RFID, which is applicable for personal tracking, access control, supply chain management, then book tracking in libraries, tollgate system. Okay, so these are the application. One is personal tracking, access control, supply chain management, book tracking in libraries. Another one is tollgate system. Okay, main operation of RFID. Generally, this RFID consists of two components. One is RFID tag. This RFID tag is nothing but it is a transponder. Okay, so which is located on object, you see here, which is located on object that can be want to identify and transfer a reader. Okay, transfer the reader. Okay, this RFID, which consists of the radio frequency model. Okay, it is also having the radio frequency model inside the RFID. It is a radio frequency model and a antenna coil. Okay, antenna coil which generates very high frequency electromagnetic fields. Okay, you see here, which generates very high frequency electromagnetic fields. On the other hand, the tag is usually a passive device which consists of just an antenna and electronic chip. Okay, this is a electronic microchip. Okay, so when it gets near to the electromagnetic field of the transceiver, due to induction principle, a voltage is generated in a antenna coil. This voltage which serves as power for the microchip. Now the tag is powered to exact the transmitter message from the reader, and this message, you see this message will be called a binary signal. It will be in pulse signal. In x-axis will be the time, y-axis will be the load. Okay, so this on and off pulse, you see here, this one call it as, okay, the top portion called as on pulse, this bottom portion called it as a off pulse. Okay, simultaneously this on and off pulse will be there. Okay, so from the transmitter it will be transferred to the RFID reader, will be in binary numbers. Okay, will be in binary numbers 1 and 0. Wherever it is on, you will get 1. Wherever it is off, you will get 0. Okay, any doubts? Any doubts?
No, sir.
Okay. What are the enabled components with access control in home automation? Generally, this most of the RFID system consists of tags that are attached to the object to be identified. Each tag has its own read only or rewrite internal memory depending on the type and application. Okay, so there will be a typical configuration of memory which is used to store the product information. Okay, for each and every object there will be unique ID number which will be generated. You see here, In home automation, there are 5 components are there. One is tag, another one is antenna, third one is reader. Reader means which is the receiver of the tag information or manipulator. Fourth one is communication protocol, communication infrastructure, which enable our reader RFID to work. Fifth one is application software, user database application or interface. You see in this diagram, okay, this is a RFID reader. With RFID reader, there are series and parallel. There are 2 pairs of tags which are connected with each other, and whatever the signals which are receiving from the tag, it will be sent to the computer, okay, through a digital information which is to be sending. Okay, generally in RFID system, the electromagnetic energy which will be a signal which will be generated by a reader, which will trigger the tag to reply to the query. Okay, the query frequency up to 50 times per second. Okay, so here they are using the protocol called ISO 15693 and ISO 18003 for high frequency, and for ultra frequency, very high frequency, it comes around the 18006, and EPC for UPF begins the identification process when the reader is switched on. Okay, generally in RFID system, the protocol works on selected frequency bands. The range will be for UHF 860 to 915 MHz or 13.56 MHz for very high frequency. So these protocols will works on selective frequency bands. So for UHF it works on 860 to 915 MHz. For HF operate for 13.56 MHz. Okay. The theory content which is available. So here in this RFID system they are using the articulation algorithm. Okay. Thank you. Please watch this video.
RFID stands for Radio Frequency Identification. It is a technology that enables not only the contactless identification of objects, but also data exchange. An RFID tag or transponder contains the current workpiece data that can be updated during the ongoing production process and accompanies the workpiece from the beginning of the production to delivery. This data could include part number, material name, etc. An RFID read-write device has access to the transponder data and forwards it to a PLC or simultaneously to a host computer. Each transponder has its own RFID number. This allows for flexible activities during the production process. Yes, even a production size of 1 is possible. RFID is one of the important enablers for smart factory. Here you see the basic components of a typical RFID system. The RFID reader sends a constant radio wave via an antenna. The tag, or so-called a transponder, receives this signal and responds with its own radio signal containing the information stored in its memory. The reader decodes this information and passes it on further, typically to a host computer. In 1935, the Scottish physicist Sir Robert Alexander Watson Watt invented the radar detector. The problem was that it could only detect objects at a certain fairly short distance. It was also Watson Watt who developed in 1937 the system called Identify Friend or Foe, or in short, the IFF system. Here, a transmitter installed into a British aircraft could detect the radar signal from the ground airfield and broadcast a signal back to the base to identify the aircraft as friendly. At that time, the transponders were the size of a suitcase. Today, you see RFID almost every day, from the location chips in your dog to automated toll collection systems to Apple Pay. One reason this RFID technology, which we also use in our daily lives, is so successful is that the tags can be built very small and cheaply. But wait, each electronic device must have an energy source, and batteries are bulky, and you have to recharge them. passive RFID transponders resolved this problem by receiving their required energy completely via an electromagnetic energy field from the RFID read-write device. Furthermore, data can also be transmitted bidirectionally via this energy field. Because energy and data are transmitted via one coil simultaneously, you need a demodulator to extract data from the energy during an upload. The new information can then be stored in the memory, which has to be, in this case, an EEPROM, as you have a read-write transponder. The encoder and modulator are active when the tag is read out. Small in size, cheap, and with an almost unlimited lifetime, these passive RFID transponders are the most commonly used. What you see from this draft is that the distance range and data transfer mainly depend on the frequency. These frequencies are fixed and the components are not interchangeable. That's also because each frequency range requires its own antenna. In general, it can be said the higher the frequency, the smaller the antenna. If RFID technology is used in logistics, for example, larger distances must be covered, sometimes up to several hundred meters. Here, so-called active transponders must be used. The transponder is normally in so-called sleep mode and is only activated by the RFID read-write unit when a data transfer is to take place. This can increase the service life of the transponder's battery up to several years. Advantages are, for example, increased range, lower signal runtime, higher data transfer, and the option to read several tags at one time. But on the other hand, the tags are large, costly, and have a limited lifespan due to their battery. The last type of RFID tags are the so-called semi-active tags. As the name suggests, this device incorporates some active RFID features, such as a battery to provide power for its memory and passive RFID features for data transmission purposes. These tags have a longer lifespan than active tags and are less costly. Is the so-called backscatter modulation. The principle is simple. The coils of the read-write device and the tag are coupled via a magnetic field. When one of those coils are shorted, it changes the inductance of the other coil. Watch the switch of the tag. Switch open stands for the binary information 0. Switch closes, and we have binary data 1. However, the change of the signal is very small, very susceptible for noise, and useful for small distances. One option would be frequency shift keying. To transmit a binary information, two discrete frequencies are used. As you see, the space frequency represents logic 0 and the mark frequency logic 1. In phase shift keying, the phase position is switched between 0 degrees and 180 degrees, as we see here. Now you have a much better idea of how.
Any doubts? Students, any doubts? Any doubts? Okay. The attendance, I will give attendance to all the students. Okay. And one more information, yesterday I have shared, the department has shared the co-curricular activity, right? So as per the co-curricular activity rubrics, you people are having certificates. Maybe you got the information from your class teacher to submit the certificates by next week, right?
Yes, sir.
Okay. So as per the rubrics only, we are going to provide the marks for all the years, including second year, third year, final year, like that. So better don't cook the certificates. Please attend the courses and submit the certificates. Okay. So I think Sarthak, you have the Coursera certificate, right?
So last time we had.
Last sem certificates I am not consider.
So because that was related to the machine learning, I mean the machines thing, this time
No,
regarding
actually we
automation
already
there is
provided the
no.
marks for last semester certificate. We already
Yes, sir,
provided.
but regarding automation there is no such question
Automation,
sir.
for automation what I will do, I will share one Schneider Electric Coursera portal. Okay, Schneider Electric Coursera portal to your group. Okay, so
Okay,
please
sir.
log in that. This instruction is applicable to all the students. Please listen carefully. I'm going to give the link of Schneider Electric Coursera portal. There are plenty number of courses which are conducting by the Coursera. Okay, per day you can complete 2 courses, 3 courses per day. Okay, it will be very easy to complete it. Just to watch the video, that is enough. No quiz, no test, nothing is there. You need not to pay any amount. Okay, when you get into the login, you have to register it as a student, and you will get username, password, and register it. Okay, and log in it. And once you log in, there is a courses will be there, and you please find the courses. Okay, so if you have any doubts, please call me, then I will create a Google link, then I will explain how to access the course Schneider Electric courses. Any doubts?
So it will be better if you send the Coursera link as soon as possible.
Coursera link as soon as possible. Once again.
Because you had your 4 days for submission, that's it.
Sir,
Give an explanation, sir.
Oh, what?
Give an explanation to access it, sir.
Schneider Electric will be there. Danfoss Industry courses are available. Okay. This is the portal snyderuniversity.com. Okay, please note down snyderuniversity.com. I'm posting in the chat box also. Okay, someone please copy that link and please send it to your unofficial group. Don't put it in your official group. Please put this link in the unofficial group. Snyder University. Okay, here you have to register it. Okay, here there is a new user register. The screen is visible. Screen is visible.
Yes, sir.
Okay, here new user register is there. So once you click, there will be a dialog box will be open. There you give all the details. You will get a username, password. Then give the submit button. If you give the submit button, there are a course catalog. Everything is available. So here you see the course catalog. Okay, and courses by energy efficiency courses. See, there are plenty number of courses are there. You see, these are all Coursera. It will be industry course. Okay, for that purpose only the rubrics I have given a 10 out of 10 if you completed the courses. It is purely related to your home automation. Okay, for all the subjects you can complete the course here itself. Okay, so once you complete it, once you click this button, you will get the course. Okay, one by one you can complete it. Okay, so like that please complete the course and what is that, get the certificate. Any doubts? snyderuniversities.com. Okay.